Priyanka Kunde, and I made this video for TYBCS students on computer graphics, in which I teach you clipping chapter. Let's see. In this chapter, first we see what is a clipping. Clipping is a process in the computer graphics which is used to remove the objects, line or a point that are outside the viewing plane. Means, in other words, we can say that clipping is a process of extracting a portion of a database or identifying the elements of a scene or a picture inside or outside a specified region. It's called as the clipping region. Means, if I have a mobile and according to my mobile size or a camera size, if I capture one picture in this, then according to the mobile's window, I capture that scene. Means the scene outside from my capturing picture are not in that picture because of the boundary, and that boundary means a window, and that window is used in a clipping technique. Means the area or elements outside that clipping boundary are removed, and this technique is called as a clipping. In clipping, we have two concepts that are very important. First is window. Window means what do you want to see, and viewport means where do you want to see it. Means viewport is a device coordinate. Let's see next. Here we have one figure in which we focus on world coordinate system and device coordinate system. In world coordinate system, we have a window or a monitor. Let's see. It have a Y window max, Y window mean, WX mean and WX max. These are the coordinates for that scene, where scene is located. Let's see. This window cut the portion of that scene, and whole system is called the viewing coordinate system. Means in this coordinate system which we viewing, where we use the window for it, and I think from the picture you can see what is a window. After that, the second big concept is device coordinate system. In device coordinate system, we use viewport, and we, as I said, viewport is a concept which is for where we want to see. When we select these window coordinates, we can see it on a device by calling it a viewport, by using viewport, and I think you got the idea from this picture. So, in this next line, x coordinate of a given point is inside window with x lies in between wx1 and wx2, which means x, if we have a point, and we know that in graphical system a point have a coordinate x and y, then we want to check that x is lies between window x1 and window x2, which means minimum and maximum limit, and for y coordinate which must need to check that y is lies between window y1 and window y2, means minimum and maximum limits of a y. Got what is the concept of a point clipping, and it is very. After that, we have a concept line clipping. Line clipping means a concept of a line clipping is same as a point clipping, but in line clipping we will cut the portion of a line which is outside of a window and keep the portions of a line which are inside the window. And as we know, at least 2 points need for a line. So for this, I think I need to explain the Cohen-Sutherland line clipping algorithm. So let's see. First, I introduce this. This algorithm uses the clipping window as shown in following figure, and the minimum coordinates for the clipping region is x window mean and y window mean, and for maximum coordinate is x window max and y window max. So let's see this figure. These are lines which are drawn in red color, and the window which is drawn in black color. Let's see. X window mean and y window max. Next here we see on the right side X window max and Y window max. After that, X window max and Y window mean, and X window mean and Y window mean. Means we have a minimum and maximum limits of the XY coordinates. Let's see a line and first we see the clipping window and that line. See, one line is completely between this window, one line which is beyond the minimum limits, which is completely outside the window, and one line is partially inside and outside. So for this Cohen-Sutherland algorithm, we use 4 bits. These 4 bits represent the top, bottom, right and left regions of that particular point of a line. Here top left bit is set to 1 because it is the top left corner. So let's see, and these 4 bits are called as a region codes, because these 4 bits are used to find out the region, and that's why it is called as a region code. This is a window which is drawn in black color, and inside this window we have a center coordinates, region coordinates, which are 0, 0, 0, 0. Means left, right, top, bottom, all bits are 0. After that, above this region code 1,000, below 0, 1, 0, 0, on the diagonal left corner 1,001, on that side 1,010, after 0,010, 0,110, 0,100 as I said, 0,101 and 0,001. Here we have a 9 positions, and for these 9 positions we have a 4 bits which is called as a region codes. So let's see, first is the top, second is the bottom, third one is the right and then left. This is a mechanism which is used for this Cohen-Sutherland algorithm. Let's see, for this, by using this flipping window, here we have 3 cases or 3 possibilities. First is line can be completely inside the window. This line should be accepted. If we find a line which is completely lies, means the points have 2 endpoints are completely inside that window, then this line is completely inside and we should be accepted this line. Should we accept this line? Next possibility is if line have 2 endpoints, both are outside the flipping window, means the line is completely outside and we can remove or reject that line from the region. And third possibility, which is the line is partially inside the window, which means one endpoint is outside and one endpoint is inside the flipping window. These are the 3 possibilities. We need to study it for our algorithm. Algorithm is very easy. If we understand or focus on these 3 possibilities, first step is assign a region code for each endpoint. Means a line is, we all already know that every line should have at least 2 endpoints. So a line is made up of 2 endpoints. So we need to assign a region code for these 2 endpoints. This is the first step. Second step is if both endpoints have a region code 4 times 0, means left, bottom, right, top, all these bits are 0, then accept these lines. If 2 endpoints have a region codes both 0, 0, 0, 0, 0, 0, 0, 0, then accept that line. Third step is else. Perform the logical AND operation for both region codes. Means one endpoint have a 4-bit region which is not a 0, 0, 0, 0, and second endpoint which has a region code which are not a 0, 0, 0, 0. Then we need to take a logical AND operation of it. And if the result is not a 4 times 0, then reject that line. Why? Because this line is completely outside the window. Otherwise, we need to clip in. Then we have again 3 sub steps in it. Choose an endpoint of a line that is outside the window. We need to choose the one endpoint of a line which is outside the window. Next step, find the intersection point of that point at the window boundary. Means that point which is outside the window, we need to check or we need to find the intersection of that point with that window boundary. Third step is replace the endpoint with the intersection point and update the region code. Means we need to replace endpoint with the intersection point. Why? Because a point is completely outside, then we find the intersection points, then we replace that outside point by that intersection point and we can update the region code of that point because point is changed, so region codes need to be changed. The next step is repeat these steps too. Means second step means finding the region codes until we find the clip line either trivially accepted or trivially rejected, which means repeat the step 2 up to when we find the line completely within the window boundary or outside the window boundary. And last step is repeat the step first for other lines. Means from step first, repeat this procedure for a next line. And this process is still continue when all lines are find out whether that inside or outside. I think you got the algorithm. Figure. We have one line completely inside, we accept it. One line is completely outside from left side, we completely reject it. But here we have 2 lines which are partially inside. Then the part which is from outside with the window boundary, we can cut it and the intersection point of that window and of that line, we consider it the second point and we find out the region code for it. Means this procedure will continue or for finding the half portion of that line, half or below that portion which is within window, we can accept that portion and which is outside, we completely reject that portion. Here, last is a polygon clipping. A polygon can be clipped by specifying the clipping window. Means here for polygon clipping, we also use a window. Further augment polygon clipping algorithm is used for polygon clipping, and in this algorithm, all the vertices of the polygon are clipped against each edge of the clipping window. First polygon is clipped against the left edge of the polygon window to get the new vertices of polygon. These new vertices are used to clip the polygon against the right edge, top edge, bottom edge of the clipping window as shown in figures. This is our polygon and clipping window. Start clipping. Figure clipping left edge means first we remove the left edge. Clipping window and polygon. Here see. Next is figure clipping the right edge. Means the portion which is of a polygon which is outside the window are cut. Next clipping top edge means this in third figure, the edges which are outside the window, then these edges of a polygon are totally clipped. And last, finally in fourth figure, we have a polygon with the window whose edges are completely inside the clipping window. Okay? I think this is very simple to understand. Thank you for the session. If you have any comments, queries, problems according to this topic, please comment or mention in comment section by subscribing it. And if you want to other video on other lecture or other topic, then also you can mention it in comment by subscribing. Thank you so much.